Find the sum of the first 20 terms of the arithmetic progression minus 9, minus 3, 3, and so on, where arithmetic progression refers to a sequence of numbers where from one term to the next you're adding the same number. So notice from -9 to 3 we're adding 6, and from -3 to 3 we're adding 6 as well. So we need to figure out how to add the first 20 terms in this sequence of numbers. And before we look at this specifically, let's think about adding an arithmetic sequence of numbers in general. So let's say we're summing or adding n terms in an arithmetic sequence where the first term we'll call A, and then the next term will just be that same first term plus some common difference between each number. In this case, D would be 6, and our first term would just be -9. So think about this. If you had -9 for this, and -9 here plus 6, that would give you -3. And then plus that first term again, plus now twice that common difference. So -9 for us, plus 2 times 6, or plus 12. -9 plus 12 is 3. So you can see that this pattern matches up with the numbers in our sequence. And then we're going to keep adding all the way till we get to the nth term in our sequence. If this is the first term, this is the second, this is the third. Notice that the term number we're on is always one more than what's multiplied by D. So this would just be A, our first number, plus n minus 1 times D. And there's a nice trick we can use to be able to add this entire sum. Okay, if I rewrite the sum just with the terms reversed, we would have A plus n minus 1 times D plus A plus n minus 2 times D plus A plus n minus 3 times D, and all the way down to A, our first starting term. And then what we can do is just add both of these sums together. So adding both of these on the left-hand side, we'll just have S sub n plus S sub n, which is 2s sub n. And this is equal to, now let's add it, the first one here plus the first one here. So we're adding both of these. Notice we just have an A, and we can add that to this A. So we have 2A plus n minus 1 times D, and then plus, now we're adding the second terms in each. So we have A plus A, so that's another 2A. And then here we have n minus 2 times D, and we're adding one more D to that. So this would become n minus 1. So we have plus n minus 1 times D. And then now we're adding the third terms. And again, we have 2A's plus, and here we have 2D's, and here we have n minus 3D's. So adding 2 to this, we would be at n minus 1 again. So n minus 1 times D. And we're going to keep adding all the way till we get to the last terms in this and add these together. We'll again have this 2A plus n minus 1 times D. And then solving for S sub n, notice we have the same thing, and we have it n times, since there are n terms in our sum. So it's really just n multiplied by this thing. So 2A plus n minus 1 times D, and then dividing each side by 2 here, this is all just divided by 2. And this is the general formula for the sum of an arithmetic sequence. So now all we have to do is apply our specific sequence. So we know that in this case our D is this 6 here. The number of terms we have, our n, is 20, and our starting value, a, is -9. So if we just plug these into our formula, we'll get the sum of the first 20 terms of this progression. So let's do that. So our S sub n is n, which is 20, and we have divided by 2, and then twice the first term, so twice -9 plus n minus 1, so 20 minus 1, which is 19, multiplied by the difference, or 6. Okay, now we just have to simplify this. So 20 divided by 2 is 10. 2 times -9 is -18, plus 19 times 6. 6 multiplied by 10 is 60, and 6 multiplied by 9 is 54. So 60 plus 54 is 114. And then minus 18 plus 114 would just be 96. And 10 times 96 is 960. So the sum of that arithmetic progression is simply 960. And when you're actually taking the CLEP test, this derivation might take too long since the CLEP test is timed. And your best bet might be to just memorize this formula, though the formula is fairly bulky, and there's actually an easier way we can remember it. So if I rewrite it, S sub n, as n times a plus n minus 1 times d, and this is all divided by 2, we can notice something. So if I group this a little bit differently, so there and there, notice that this is just, a is just our first term, and a plus n minus 1 times d might look familiar. Here in our sum, remember this is the nth term, since we reverse the order here. Here's the first term. And if I call the first term a1, and I call the nth term a sub n, then we can rewrite the formula as just S sub n is n times the first term plus the last term, all divided by 2. And you can think about this expression in parentheses as just the average of the first and the last numbers, and then multiplied by the number of terms you have. So when taking the test, this might be easier to remember, and then you'll just have to think about how to find this nth term.